Good day, grade 11s. I hope you guys are okay. Welcome in NTLAMZA'S chamber. If it is your first time joining this channel, you are welcome and thank you for joining. Okay, today I'm going to do the topic of electric circuits. So since you guys are in grade 11, this is the continuation of what we've done in grade 10. Okay, so without wasting time, let me get into matters. By the way, my name is Untitled. My surname is Basimani. I'm the presenter here in this channel. Okay, so we are given a circuit diagram here with a question or an opening statement actually. So the opening statement says 3 different resistors are connected as shown below. The battery has an EMF of 30 volts. The resistance of connecting wires and battery is negligible. Okay, so we are given the diagram here showing us an electric circuit. So when we analyze our circuit, we notice that we have different resistors. We also have the EMF of the battery. So as all of you can see that the current is going to flow from the positive terminal of the battery coming all the way until it reaches this point. At this point the current is going to split. So it means that these resistors are in parallel combination because of they are parallel with each other, and the current is going to split when it is going to pass through these resistors, and then the current is going to go and then combine again here at this point, and then going to pass through the 18 ohms resistor as a whole. Okay, so it means that this resistor now it is in series with our battery, since the whole of the current or the total current of the circuit is going to pass through this resistor. And then we are given these 2 cells or the battery, which has the EMF or the electromotive force of 30 volts. Okay, so the EMF or the voltage, it is the total potential energy that the battery can supply to all of our resistors in the circuit. Okay, so I have these questions here. Okay, I hope they are visible. Okay, so 7.1 says, what is the total resistance of the circuit? That is question number 7.1. It says, what is the total resistance of the circuit, or calculate the total resistance of our circuit. So we want to know what is the total resistance here in our circuit. Okay, so it is 7.1. okay, so based on the calculations, not the calculations actually, but then based on the formulas that we have learned in grade 9 and 10, we were told that the total resistance of a circuit is the same as the total resistors that are in series plus the total resistors that are in parallel. Okay, so we have this resistor that is in series and then these ones that are in parallel. So we're going to substitute. So total resistance is equals to the resistor that is in series. We have only one of it, which is 18 ohms, plus the resistors that are in parallel, which are these ones. So we have RP. Okay, so always when we want to calculate the parallel resistors or resistors that are in parallel, always we use this formula: 1 over RP is equals to 1 over resistor 1 plus 1 over resistor 2. Okay, so it means that we have 1 over RP is equals to 1 over resistor one, we can say 4 ohms. We have 4 and then 6 plus 1 over 6. Therefore 1 over Rp is the same as let me use my calculator, the same as 1 over 4 plus 1 over 6 is the same as 5 over 12. Okay, so because of we want 1 over Rp, we don't want 1 over Rp, we want Rp. We are going to include the inverse of the reciprocal, okay, so that this one can go down and then this one can go on the top. So therefore our Rp is going to be the same as 12 over 5. Okay, so 12 over 5 is the same as 2,4 ohms. So it means that our Rp is 2,4, and then in that case you can just substitute. Therefore our RT, total resistance of the circuit, is going to be the same as this 18, the series resistor, plus 2,4. So the total resistance of the circuit is going to be 18 plus 2,4, which is the same as 20,4. Okay, 2,4, let me just confirm, which is the same as 20.4 ohms. Okay, so it means that our RT is the same as 20,4 ohms. That was the first question. Okay, and then let's see what the next question says. So the next question says, calculate the current passing through the battery. So now we are required to calculate the current that's going to pass through the battery. So obviously the current that is going to pass through the battery, they mean the total current of the circuit, because of this current is going to pass in this battery before it can reach this parallel combination. So it means that we are required to calculate the total current of this circuit. We have the voltage of the battery already, or the EMF, so you can just do substitution. Okay, so let me try to do it here. Let me say it is 7.2. Okay, so we all know that according to Ohm's law, the current is directly proportional to the voltage, provided the temperature remains constant. So this is the formula that we always use when we calculate the current. So we want the current of the battery, okay, or the total current of the circuit. So we're going to just substitute here. So when we substitute, we already have the voltage or the EMF of the battery, and then we also have the total resistance of the circuit that we have calculated here. So we're just going to say it is equals to 30 volts divided by the total resistance, which is 20.4. So we get the answer of 30 divided by 20.4. We get the current of 2 decimal place 1,47 amperes. So 1,47 amperes, it is our current. Okay, so I hope you guys understood what I've done here. Okay, so let's go to the next question. So the next question is 7.3. not 7.4, 7.3. It says, what is the current of the 4 ohm resistor? So here we are required to calculate the current of this resistor, the current of the 4 ohms resistor. So we want to know what is the current that is going to pass through this resistor alone, because of the current when it comes is going to split. The other one is going to go to 4 ohms, the other one to 6 ohms. So we want to know what is the current that is going to come to this side after it has splitted here. We already know that the total current that is going to pass in this circuit is 1,47, but when it gets here, it's going to split. This value is going to decrease. So we want to know what is the current that is going to pass through here. Okay, so let me try to create a space for that question. So it is 7.3. So before we can get the current here, we must firstly find what is the voltage of the 4 ohm resistor, because we already know the total voltage of the circuit. So this 30 volts is the voltage that is supplied to these resistors, all of them combined. So we want to know what is the total voltage of the 4 ohm resistor alone. So it can't be 30, it has to be some value, so we have to find it first. Okay, so since well we know that the V total voltage of this circuit, it is the same as the voltage of the resistor that is in series plus the voltage of the resistors that are in parallel. Okay, so we're just going to substitute. So the substitute, the total voltage, it is the 30 volts that we have been given. So we have 30 volts is equals to the voltage of the series resistor. We don't know this. Voltage of this resistor. Okay, or did we calculate it? Okay, so we don't know the voltage of this resistor. This is going to be Vs plus we also don't know the voltage of our parallel combination. Okay, so we have 2 unknown values, so we're just going to leave them like that. So what can we do in order for us to calculate the voltage of this resistor? We already know the resistor and then the current, so we can calculate the voltage here. Since we already know the current that is going to pass here, the current that is going to pass here, it is this current, because of it is the total current that is going to flow in the circuit. So we're going to say the voltage of the 18 ohms resistor is the same as the current that is going to pass through it multiplied by the resistor. So this formula comes from here. Okay, it is Ohm's law. So we know the current already, which is 1,47. So we have 1.47 amperes multiplied by the resistor is the 18 ohms. Okay, and then we get 1.47 multiplied by 18. Then we get the value of 26.46 volts. Okay, so now we know what is the voltage of the resistor that is in series, okay, which is Vs. So you can just go and substitute it here now. So what is substitute is going to have 30 is equals to 26.46 volts plus Vp. Okay, so therefore our voltage is the voltage of the parallel combination is going to be 30 minus this one. So you're going to have 30 minus answer, so which is the same as 3.54 volts. Okay, so it means that the total voltage of our parallel combination, or the resistors that are in parallel, is Vp. Okay, but in grade 9 and 10 you guys have learned that the voltage of the parallel combination is the same as the voltage of resistor 1, it's same as the voltage of resistor 2 is equal to the voltage of resistor 3. Okay, so because of this, therefore it means that this total voltage, okay, is going to be the same as the voltage is going to be measured in this resistor, and the voltage is going to be measured in this resistor. So this means that the voltage of the 4 ohm resistor is 3.54, and also the voltage of 6 ohms is also 3.54 volts because of this formula. Okay, so since now we know the voltage of this resistor, we can now calculate the current, because of the question asked us to calculate the current that is going to pass through the 4 ohm resistor. So now we can just calculate the current. So therefore current of the 4 ohm resistor is going to be the voltage of that resistor divided by that particular resistor. Okay, so which is the same as the voltage of this resistor, is this one, 3.54, and then over the 4 ohm. So the answer is going to be 3.54 divided by 4. So it means that the current that is going to pass through this 4 ohm resistor is the same as 0.885 amperes. Okay, 0.885 amperes. So that is the current that is going to flow through, okay, that is going to flow through this resistor. Okay, so you can see that it is a very small current, given that the total current of the circuit is 1.47. So because of this splitting of the current, this is the original current is going to flow from the positive terminal of the battery, and then when it gets to this point it splits. So when it splits, it means that this 0.885 amperes is the one that is going to pass through 4 ohms resistor. Okay, the remaining is going to pass through this resistor, and it is going to continue until reaching this point, and then combining again, forming 1.47 amperes that is going to pass through the 18 ohms resistor, returning back to the battery. Okay, so I hope you guys have understood what I've done there. So let's see what is our next question. So the last question is 7.4. It says, what is the power dissipated in the 4 ohm resistor? So it means that now we have to calculate the power of the 4 ohm resistor. Okay, we have to find out what is the power of the 4 ohm resistor. So there are several formulas that are used to calculate power. Okay, so when you calculate power, you can use 4 equations. The first one is power is the same as VI, and then again power is the same as current squared times the resistor, and then power is the same as V squared over R. So actually we have 3 of the formulas or equations that are used to calculate power. So since we have found the current that is going to pass, through this resistor, it means that we can just select any equation here that is going to suit what we want, okay, or that's going to help us to accomplish what we want. So we have the current that we have calculated, which is 0.885, and then this formula has current. We also have the voltage of this resistor, which is V. We can also use this formula because we have found the current of the 4 ohm. We also have the resistor, which is this 4 ohm. Okay, even this one is applicable, so it means that all of them are applicable here, since we have the values of all of the variables. Okay, so let me just use this one. So you can use any formula, you're still going to get the same answer. So I'm going to use this one, which says P is equals to current squared multiplied by the resistor. So it is the same as, so you want the power of the 4 ohm resistor. So the current that we have gotten is 0.885 amperes. So 0.885 amperes squared multiplied by the 4 ohm, So the answer is going to be 0.885 squared multiplied by 4 ohms. Then we get that the power dissipated to 2 decimal places is 3.13 watts. So we all know that power is always measured in watts. Why? Because of the power is the rate at which work is done. Okay, so power is the rate at which work is done. That is why it is measured in watts. Okay, so I hope you guys have understood what I've done in this question. So I will see you in the next example shortly. So yeah, I'm going to start the next example now.